Here is an explanation for the answer to final exam, question number 87 in Electronics Demystified, 2nd edition. If you have the printed book, you'll find it on page 436. We're talking in this question about a counterpoise. What does it allow us to do? Well, in order to explain that a little bit, I've drawn a diagram of a ground plane antenna, which is a popular antenna for use at high frequencies, shortwave frequencies. It's also quite popular on the citizens band radio part of the spectrum, 27 megahertz band. If any of you are still familiar with the 11-meter band, you will often find ground plane antennas. A quarter wavelength radiating element, vertically oriented, forms the heart of the ground plane antenna, but instead of mounting it on the ground itself, we use radials, each of which are a quarter of a wavelength long. There can be 3 or 4 or more of them. 4 is a common number, but there should be at least 3. This antenna needs to be significantly elevated above the ground in order for a ground plane antenna to work. The ground plane then is provided by these radials, which serve as a sort of an artificial RF ground, radio frequency ground. I remember seeing once a little joke. It was like it had a little piece of cardboard with a screw terminal on it, and the screw terminal was labeled portable ground. Well, there's really no such thing as a portable ground exactly, but an RF ground doesn't have to be connected to the physical ground. So if that little screw terminal had 4 1/4 wavelength wires attached to it, it would in effect form a portable ground at the frequency corresponding to where those wires were a quarter wavelength long. On 11 meters, that's about 9 feet or 3 meters long, a little less than 3 meters. Anyhow, these 4 radials, or however many there are, form a counterpoise. That is a device that serves as a radio frequency ground without having to be physically connected to the earth. The way that it works is that it provides in effect an artificial earth. If we extend these radials and make them longer and put a lot of wires between them, so we have in effect like a spider web arrangement whose radius is a quarter wavelength or more, and if we orient this entire spider web-like arrangement parallel to the surface of the earth, or to the average surface of the earth in the vicinity, we get a counterpoise which can serve as an RF ground. That's what a counterpoise is good for. It gives us an excellent RF ground, and we don't have to have a direct connection to the earth. That's choice B. Note that this kind of an arrangement will not provide us with a good electrical ground or DC ground. Not at all. If it's not connected to the earth, it's not going to give us a good electrical ground, but it will in fact give us a good radio frequency ground.